All right, guys. In this video, sorry, I had to make it a three-part video because I had to change classrooms. But again, we're still going over these practice problems. We still got to do the last one. So in part one, we did the enthalpy practice. In part two, we started the calorimetry questions practice. Okay. Um, and we finished with figuring out this one, figuring out the heat of solution for calcium acetate based on the calorimetry data. And just remember for this practice problem, if the end game is to figure out the delta H of that particular reaction, when you finally report that delta H value, you need to make sure you have the proper sign. And since we know that temperature increased as this reaction went, we know it's an exothermic reaction. So when you report that delta H, make sure you're reporting a negative number. If the temperature had gone down while the reaction went, then that would be an endothermic reaction. So when you report the delta H, it would be a positive value. Okay. All right. So this last question, the other thing that I didn't give you to answer this last question was you need to know the melting point of iron, and I didn't give it to you in this question. So understand, like, the way this question's worded, we have all the information we need to answer what this question is asking, except for we need to be given the melting point of iron. That's not something that you would have to memorize. So that piece of information was not given to you on this question, so you have to know it to answer this question. Okay, so I have that on, I think I have it on the key. Yeah, so the melting point of iron in Kelvin is 1,811 Kelvin. Okay, but again, that would have to have been given to you as well to answer this question. All right, so let's look at it. All right, so the student wants to know how much propane they're going to need to burn in order to melt an amount of iron, 15 grams of iron. Okay. So let's understand what we have to do. It's kind of like this problem here, like how much energy is required to melt 50 grams of gold, right? So the first part of this question is determining how much energy do we need to melt 15 grams of iron. So that's the first thing we have to calculate. Okay. So just like that previous problem here, the gold question, we're going to have to do Q equals MCAT to heat the iron from room temperature here, 298 Kelvin, to its melting point, 1811 Kelvin. And then we would use the molar heat of fusion that they gave us to figure out how much energy is required to melt 15 grams of iron at the melting point. And we would add those two energy values together, and that would be the total energy. Okay. And then we got to go one more step. And we're told that when 1 mole of propane burns, this is how much energy is released. So once we know how much energy we need to get from the combustion of propane, we can use that to figure out how many moles of propane we need. And then we got to go back to the last part of unit 3. They want the volume of propane, but we're not at STP. We're at standard pressure, but we're not at standard temperature. So once we figure out how many moles of propane we need, that's going to be our end value, and we'll plug in everything else into the ideal gas law, and we'll be solving for V. Okay, so that's kind of the whole process. Okay, so the first thing we want to do is, again, we're starting with iron down here, well below the melting point. We have to calculate the energy to go from iron at 298 Kelvin and heat it all the way up to its melting point. And then we have to calculate the amount of energy required to completely melt it. And we have to add those two energy values together, and that would be the total energy we need. And then we're going to be getting that energy by burning propane. So once we know how much energy we need, we can use the heat of combustion of propane to figure out how many moles of propane we're going to need to produce that much energy. And then we can use the ideal gas law to calculate the volume of propane we'll need. Okay. So step 1, Q equals MCAT. They give us the heat capacity of iron, so that's where this 0.47 came from. It was 15 grams of iron. And the delta T, how did I get that? It was 1,811 minus 298, right? That's our delta T. So we multiply it. Now, I skipped straight to kilojoules. Understand that when I multiply it by this 0.47, my answer is going to be in joules. And then I did this times this times this, but then I divided by 1,000. So that's where the 10.7 kilojoules comes from. So to go from here to here, 10.7 kilojoules. All right. But then we need to calculate the energy to melt it once it's at the melting point. So that's why we're going to, where do I have it? Oh, right here, part 2. Sorry, couldn't find it. All right. So we would take our 15 grams of iron divided by iron's molar mass times the 14.9 kilojoules. Okay. And so once we heat it up to the melting point, it's only going to require 4 more kilojoules of energy to completely melt it. So this value plus this value is the total energy I need. Okay. And then, so what I would do is I would take that energy and I would divide it by the heat of combustion for propane. And that would tell me how many moles of propane I need, right? Because it's 1 mole of propane for all that energy released. Okay. So 1 mole of propane gives me 2,500 kilojoules of energy. I only need 14.7. So I don't need that many moles of propane. Okay. So that's how many moles of propane I need, but it asks for the volume of propane contained at STP. So not at STP, sorry. If it was at STP, we could just multiply by 22.4 to get the volume. But since we're not at standard temperature, we are at standard pressure, but not standard temperature, we got to use the ideal gas law, and we're solving for V. So here's my mole value. Here's my temperature value. My pressure was 1. And I didn't have room to write in the R value, but the R value we would use here is 0.08206, right, on the formula sheet. And so based on our calculation, we would require 0.144 liters of propane to burn to produce 14.7 kilojoules of energy. And if all of that energy was absorbed by the iron, it would be enough energy to melt the iron. Now, obviously, we don't live in a vacuum, and so we're not going to get exact energy transfer. So we're probably going to need a lot more propane because we're going to lose a lot of heat from that combustion reaction to the environment. It's not all going to transfer to the iron. But this is just kind of like in an ideal situation. If all the energy produced by the combustion of propane were consumed or was absorbed by the iron and none went to the environment at all like that, then that's the minimum amount of propane required to produce this much energy. And it's this much energy required by the iron to absorb to completely melt it when it starts at 298 Kelvin. Okay. All right. So anyway, this was part 3. So I didn't think I was going to make it 3 parts, but I had to change classrooms. But again, we were just going through these practice problems. And if you understand how to do these practice problems, then you're pretty much all set for Unit 3. So that pretty much finishes up 3.3 and 3.4. Okay, we'll do some guided notes and we'll have our calorimetry lab and that kind of stuff. But that pretty much covers Unit 3 for us. We did, KMT and gas laws, and then we do an enthalpy and calorimetry, and that finishes up Unit 3. So we're wrapping up Unit 3, and we'll be moving on to Unit 4 before you know. All right. Have a good day.